So now we're going to move on from finding the side using the cosine law to how to find an angle. Now, you're going to be able to find an angle using the cosine law when you have, I call it meaning you need to know all three sides. Now, instead of writing side, 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 I'm just going to put all three sides. So when all three sides are known, you can actually use the cosine law to solve for any angle. Now, this is the formula for using the cosine law to solve for an angle. And all they've done, don't write this down, but all we've done is taken this equation, right? So this is the equation we learned in the last video. So you have the side you're wanting to solve for with the angle across from it, and just rearranging it to solve for the angle. So if I wanted to solve for cos A, I would subtract b squared, subtract c squared. So I'd have a squared minus b squared minus c squared equals negative 2bc cos of A. And then to get to the cos of A, I would divide by negative 2bc. So divide both sides. Now what we do is to get rid of this negative, we apply it up here. So you would end up with positive b squared, positive c squared, minus the a squared. So we're switching the signs on the top so that we can just put positive 2bc on the bottom. So all this equation is a rearranged version of the original formula. So this isn't a new formula, is what I'm trying to say. And I contemplate a lot about whether I should even give it to people, but I'm like, you know what, even the formula is something that you just sort of know, and like the original one, so this is one that you can just sort of know as well. So now how do you construct this? Well, the important part is the angle you're trying to solve for. You'll notice the side across from it is the one that gets subtracted. Other than that, you're just filling in the other two sides. So if I wanted to solve for angle B, I would make sure the minus b squared is on the end. The other two sides would be a squared and c squared, right? So you're just filling in the other two sides and making sure that you subtract the side across from the angle. So if I set this up as cos C, can you figure out what the formula would look like? So take a couple seconds, maybe pause the video and rewrite out this formula to solve for angle C. So hopefully you did that. So what I like to do is automatically put that side on the end, and then I'm filling the other two sides. So if I'm solving for side C, I have to know b and a. So I'm going to go a squared plus b squared, and then the 2ab on the bottom. And then we just use this formula. So when can we use this formula? We can use this formula when we know all three sides. 1, 2, 3. So this says solve the following triangle. Okay, I need to solve for the three unknown angles. So you can solve for any of them at this point. Let's go alphabetically. So if I wanted to solve for angle A, I would set it up as, not sine, sorry, as the cos of A is equal to. And then I'd have the minus a squared on the end, and I'd have b squared plus c squared divided by 2bc. Now again, I don't ever use these literal formulas. What I do is say, okay, if I'm going to solve for angle A, what's the side across from angle A? 7. So that's the one that's going to get subtracted. The other two is going to be squared and added together, and it doesn't matter what order. It could be 6 squared plus 8 squared, or 8 squared plus 6 squared. It doesn't matter because of the commutative property of addition. Okay, and then on the bottom you've got 2 times those two sides, and then we just plug it into our calculator. So we plug in 6 squared plus 8 squared minus 7 squared. Okay, now I hit equals. Or you could put your entire numerator in brackets, up to you. But I hit 6 squared plus 8 squared minus 7 squared equals. Now I have to divide by all this. So my options are, I can divide by bracket 2 times 6 times 8 unbracket, or I could do 6 squared plus 8 squared minus 7 squared equals divided by 2 divided by 6 divided by 8. Up to you. It's whether you want to use brackets and write it as it's shown, or whether you know that each of these is getting divided. Regardless, you should end up with 0.53125. And again, that equals cos A. So if I want to know angle A, I'm going to take the inverse cos of this answer that I just got. So I'm going to hit inverse cos of the answer, and to the nearest tenth, I get 57.9 degrees. Okay, so however you're using your calculator at this point to answer it, put in answers, you could also just do inverse cos and then make sure you have a lot of brackets in here. I would highly recommend not doing that. I would highly recommend getting this and then taking the inverse cos of the answer. So that's how we solve for angle A, and now we just have to go through and solve for angle B and angle C. So let's set this up again to solve for angle B. If you feel confident with this, pause the video now, right? See if you can solve for angle B. So if I was setting up, let's go for a different color. If I was going to solve for angle B, so cos B is equal to, the only important thing is that the side across from angle B goes on the end. That's the one getting subtracted. Then the other two sides, the 6 and the 7, get squared and added together, divided by 2 times those two sides. And then again, you just plug it in your calculator. 6 squared plus 7 squared minus 8 squared equals, or make sure you put your whole numerator in brackets, and then divided by either bracket 2 times 6 times 7 unbracket, or divided by 2, divided by 6, divided by 7, whatever makes more sense in your head. That is 0.25, so you should be at this point now that the cos of B is equal to 0.25. So now to solve for angle B, we take the inverse cos of this answer. Now this is a nice easy one, so I could just type it if I wanted to, but I'm going to go inverse cos of the answer, and to the nearest tenth I get 75.5 degrees. Now my last angle is angle C. So my last angle to solve for is angle C. I now know angle B is 75.5. I now know angle A is 57.9. As soon as you know two angles in a triangle, I could find angle C by doing 180 minus the 75.5 minus the 57.9, because all angles in a triangle add up to 180. So I could do, and now technically I should keep them unrounded, which I didn't write them down as. I have one of them. Let's check it though. So I don't have my unrounded answers. So always keep your answers in case you end up having to use them again. I think, let's see what I get. So I get 46.6 degrees. This might not be right. Be careful. So the way I should have done this is I should have kept my unrounded answers to make sure I'm correct to the nearest tenth. Let's see if I got it right. So let's set this up as the cos of C is equal to. So again, you're going to subtract the side across from C. So we're going to subtract the 6 squared, and then we have the 7 squared and the 8 squared divided by 2 times 7 times 8. This could also kind of let us know if we've made a mistake, if the 3 don't add up to 180, or if I don't get close to this. So let's plug it in. 7 squared plus 8 squared minus 6 squared equals, divided by bracket 2 times 7 times 8, or divided by 2 divided by 7 divided by 8, whatever you prefer. Okay, and then we'll take the inverse cos of that answer, and we get 46.6 degrees. So we got lucky. Okay, so even though I used my rounded answers, it ended up accurate to the nearest tenth, which does happen. But it was also a good way to check that I did my cosine law correctly. So that's how to use the cosine law to solve for an unknown angle. And to do it, you have to know the three sides.